In this episode, I'm gonna present you how to set entities and relations between them based on previously prepared MySql database. If you are not familiar with Spring Framework, entities are our tables models representation in form of Java code. By marking class with @entity, we let know Spring Boot that our class is one of the entity model. Spring Boot automatically configures settings for us, so we can focus exclusively on business logic. Before we start coding, let's modify one of application properties parameter. To omit time zone issue that occur as a default in our database, bring by deprecated time zone setting, we have to add few parameters to URL address. First, we set database to use standard set of characters. Next, we set annotation to use server-side time zone settings. After that, we disable legacy data time and at the end, we set our time zone to UTC. Second thing to do before we start is to slightly modify our MySql database tables. Open settings of orders table and delete foreign key that is related to detailed order table. We don't need this relation because we are gonna mapping our tables by assigning ID of order to each related detailed order column. Save changes. Now we go to detailed orders table. Assign new column that I mentioned before. So every detailed order will be assigned to certain order by its ID. Go to Foreign Key tab and set this connection. Choose Reference Table. Mark our newly created column and assign ID column of order table to it. After all, save changes. Next thing that we have to fix is to set amount column inside product table to indicate number of available items of certain product inside our store. As always, we set this column to store integers values. Save it. Last thing to fix in our database is to set username and password column to customer table. You know how it goes. Username and password will be of varchar data type. Additionally, set those columns to not null. Set some order inside our table by moving those columns to the top. Username inside store must have unique value, so mark this box to set it up. As always, save changes at the end. Now it's finally time to write some code. To keep some order inside project, create directory for entities. These are models of our table. Create new Java class with name customer. Remember to write classes starting with capital letters. To indicate this class as any entity and let Spring Boot to configure it for us, mark this class with @entity annotation. Choose Java persistence package. Next annotation @table indicates that we want to map this model with table of name customer inside database. Let's set first field. First field is ID number of type long, just to extend range of numbers comparing to, for example, integers. Assign @id to this field. Add generated value annotation setup strategy how those values are gonna be generating. Generation type identity indicates that IDs are gonna be generating automatically for us, so we don't have to set them up manually. Add column annotation means to which column we want to assign this value inside database. Set unique to true to programmatically check if our username is unique. Name has to be exactly the same as one as we set inside database. Java naming convention standard is to use camel case syntax, so we are obligated to set @column annotation to each field. Last field to set is a list of orders that we'll be assigning to each customer. We use list interface with order generic type. We haven't created order class yet, but don't worry about that. IDE will find it from package once we create one and fix import by itself. Now comes the most important part of this class, which is mapping to order table. By adding @one-to-many annotation, we set relation that one customer can have many orders belongs to. Mapped by attribute is using to set bidirectional mapping by adding referencing site as customer. Next attribute fetch with assigned fetch tab lazy indicates that we want to load data on demand by invoking getter method of this class. Cascade attribute with assigned cascade type all means that when we delete customer, we will also delete related orders to this customer from database. All means that on every action like update, merge, persist, etc. will affect related customer order. Last attribute is orphan removal, which set to true indicates that if parent of this class will be removed, this class will be also removed when it's no longer referenced from parent entity. Once we've done that, create default constructor for this class. Now let's use IDE feature to automatically generate constructor for us with all parameters. After that, generate getters and setters for all fields. Last thing to do is to set method to add order to order list. In case of not existing ArrayList object, create new one. This ensures that we won't get any error. Invoke method to add order to list, and we have to do the same on the other side of mapping by adding this customer to order that we want to combine with. This ensures that we have a reference to each other on both sides of relation. Next table in our sequence is order table. Create new class starting with capital letter. Add annotation that you are already familiar with. Create first main field, which is ID, with add ID annotation and annotation specifying generating strategy. Additionally, you can provide add column annotation, but if your variable name is the same as inside database, it's not necessary. Here comes the most important step during creating this class. Write add_many to one annotation to map order table with customer table from the other side of relation. First, we start with fetch type. Like previously, it will be lazy fetch type. Now let's define cascade type. This time we don't want to delete customer during deleting order entity. So we limit cascade to merging, persisting, detaching, and refreshing. Order table is the owner of foreign key, so we have to add join column annotation with the name of foreign key to define that. With this, we have now established a bidirectional association between those two classes. After that, we set similar association to the one we already established. One order can contain many detailed orders assigned to it. Sorry for this mistake, will be corrected at the end of writing this annotation. We are following the same steps like in customer class. Because this class doesn't own foreign key, we set mapped by attribute to this class. Cascade set to all because we want to delete all related detailed orders if this order will be deleted. Detailed order without order doesn't have much sense to exist. Last, orphan removal to remove this entity when parent of this class is removed. Create list of detailed orders that we'll implement later on. Last two fields are date of order and date of delivery of type date from Java util package. In order to assign automatically date during of persisting object to database, let's add method with add_prepersist annotation. Assign new date object to order date variable. Create default constructor. Generate constructor with all available fields and also getters and setters. At the end, just like in customer class, we have to create method to add detailed orders to list. Just like before, check if array exists, if not, create new one. Add object and add reference to this class to recently added object, so we will combine them to bring awareness about relation. Order class is ready to go. Let's create detailed order class. As always, use camel case. Add annotations to indicate that is entity and to which table it belongs. Add ID field exactly like before. Now to establish association with order table, we add add_many to one annotation. Fetch type lazy like always. We eliminate cascade delete from this set because we don't want to delete the whole order when customer resigned from one product. Add join column with foreign key name to mark this table as a owning side of relationship. One detailed order can have assigned one product, so we establish one-to-one association with product class. Of course, we have to limit cascade to not delete product while deleting detailed order. Copy from the previous field. Add a join column because this is the owning side of storing ID of product from product table. Last field is amount that indicates how many items of this product we want to order. Add default constructor. And like before, generate constructor, getters and setters. Don't forget to change table name to plural. Finally, last class in this episode is product class. You know how it goes. Create one, add annotations to set this class as an entity, and set related table. Add ID just like before. Create name and category fields of string type. Add price field of double type and last field amount of type integer, which indicates how many of this product are available inside the storage. Add default constructor. Generate constructor with all fields. Generate getters and setters. In this class we don't set any persistence annotation because product is separate entity which is not aware of its usage. Our database model is ready. Thank you very much for watching.